This week we're going to talk about most of the basic 3D modeling tools and commands. If you'd like to follow along in the file, in the Saved Views dropdown, you can click on any of the views. They're all numbered, and that will take you to that point in the file. This is a good example of the way that layers and saved views work together. Many of the tools have multiple views, so each tool or command is on its own layer, and then the saved views command is used to save the particular view that I want you to see. Most of the tools we're going to be using are in the 3D modeling tool set, so make sure that that is open. And there are some also in the menu, but most of them are over here. So we're going to start with 3D polygons and NURBS. In order to talk about a 3D polygon, let's first talk about a 2D polygon. So the 2D polygon tool allows you to draw a polygon that has the corners or the vertices coplanar, meaning they're on the same plane, which means that the object is flat. It's 2D. The 3D polygon tool allows you to draw shapes that have vertices that are in, sometimes it's hard for me to actually do this. Let's see if I did it. Oh, that one is 2D. So that was going to be the next thing I said, is you can use the 2D polygon, the 3D polygon tool rather, to draw shapes that are in fact coplanar, that act as 2D polygons. But it's normally used for drawing shapes that are three-dimensional. The NURBS curve tool does the same thing for curves. So let's see if I can actually draw one that's flat. I think that, yeah, there we go. So you can use the NURBS curve to draw flat curves, but primarily you'll be using it for drawing curves in 3D space. So when drawing the 3D shapes, I sometimes find it difficult to actually figure out where to click in 3D space. It's useful to have some sort of guide or scaffolding, if you will, to build on. So if you go to 1.2, these are the cubes that I drew in order to use them as scaffolding to create the curves in the previous slide. So if you use the 3D polygon tool and click on, well, really anywhere, any of the available points, and you'll have all of the corners and the centers to click on. So you can see how using this as a guide can be helpful to drawing 3D space, and you just have to know what your final object is going to be, and you can create a guide that's appropriate for you. So try that out. Use the 3D polygon tool and just see what shapes you can draw using the cubes as a guide. When you're finished, double click. That completes the 3D polygon, and the NURBS tool works the same way. Try that out. Use it to see what shapes you can draw. If you complete the shape, you don't have to double click. If you go back to, if the ending point and the starting point coincide, and that is true of most Vectorworks tools, if you're completing a shape, it will complete itself if you go back to the original point. But so give that a try and see what you can draw. And also, just for trivia's sake, people every semester always ask, what does NURBS mean? NURBS is a mathematical formula used to define three-dimensional curves, but it stands for non-uniform rational B-spline, in case you're ever on Jeopardy and need to know that. Next up, 2.1, we have extrude. You should all be familiar with extrude after last week's project, but I just wanted to make sure to gather all of these tools in the same file for future reference. So just briefly, you can extrude a 2D shape into 3D space by using the extrude command. positive number extrudes up, a negative number extrudes down. The extrusion always happens perpendicular to the face of the 2D object. So if you draw a 2D object in top view and extrude it, it will either extrude up or down. If you draw a 2D object in front or the side views, it will extrude forward or backwards. You can extrude polygons, you can extrude lines, you can extrude polylines. You cannot extrude NURBS curves. There is a way to get them into 3D space, but the extrusion command will not work. Remember that you also can always use the object info to alter the extrusion. You can change that from 1 inch to 12 inches if I hit enter. Let's actually try that. 12, enter, there we go. Depending on the 2D object, you also can sometimes change the 2D object. Since this is a circle, I could change the radius if I wanted to. In object info, you can always also just double click on the extrusion to get back to the original 2D object and alter it if you need to change anything. We're going to clip surface there and delete that. So that is the extrude command. Up next is multiple extrude. Multiple extrude allows you to take two objects and create an extrusion using one of the objects as the bottom and one as the top. So if you create two objects, select them both and use the command model multiple extrude and give it a height or an extrusion size. It will create an extrusion using the bottom shape as the bottom and the top shape as the top. And what I mean by that is the stacking order. Speaking of which, if you go to 3.2, these are multiple, and you can use more than one shape. It doesn't just have to be two. It will evenly spread out the shapes between the top and the bottom if you use multiple shapes. And Vectorworks uses a stacking order. So the order in which you draw the shapes determines the stack. The first shape that you draw is on the bottom of the stack, and the last shape that you draw is on the top of the stack. So if you select all of these objects and use model multiple extrude, I'm just going to leave the same 4 inches. You can see that it draws this bizarre shape. It's a little bit like a folded paper crane or something. I don't know. But if we go into, if we double click and go into this and, for instance, send the blue object to the back, modify send to back. Oh, it was already in the back. Let's send it to the front. Model send to front. There we go. You'll see that it changes the shape. So if you double click on that and just sort of play around with the stacking order. Unfortunately, it doesn't tell you anywhere, like in object info, what the stacking order is. You just have to sort of know that you drew the blue one first and then the red one. And there are commands to not only send to front and back, but also send forward and backward, which will send it forward, sends it forward 1 in the stack, and send backward sends it back 1 in the stack. And so let's take this red one and just send to front and see what happens. So yeah, that radically changed that. So just play around with the stacking order there and see what you can come up with. I should say here that objects that are similar in their number of corners or vertices multiple extrude much better than objects that are different. So for instance, if you try to extrude a square, multiple extrude, a square and a circle, you will probably not get the result that you expect. But let's try this and see what happens. Model multiple extrude. Yeah, it gets confused and doesn't know what to do, because the program attempts to align the vertices of the bottom object to the vertices of the top object, and it doesn't know with the circle which point on the circle corresponds to which corner of the square. So you don't get what you would think you would get. You get something that's kind of cool, but this probably isn't what you were expecting. There are ways to create the shape that you would expect if you're doing this extrusion, but multiple extrusion is not the way. So generally speaking, the objects have to have the same number of corners, or you get a very strange result. Up next, 3.3, tapered extrude. Tapered extrude allows you to extrude with, wait for it, a taper. You select the object, use the command tapered extrude with a height and an angle. I'm going to make this 10 degrees, and it extrudes the object to that height using that angle. Pretty straightforward. Positive angles taper in. This has always seemed a little bit backwards to me. And negative angles taper out. So if we change this to minus 10 degrees. And the angle, of course, supersedes the height. So this is currently extruded 4 inches at 10 degrees. If I change this to 45 degrees, it will say that the height is 4 inches, but that is obviously not true. This one is also 4 inches tall, because at 45 degrees, it will only go as high as it can go until you run out of angle. So just be aware that the angle supersedes the height. If I change that to a negative 45, then it will work, because of course the negative angle, it can always taper out forever. It can just only taper in until it runs out of angle. That's a strange shape, so I'm going to change that back to regular 45. Okay, so tapered extrude. So give that a try, play around with these, and see what sort of exciting tapers you can come up with. (4.1) Extrude along path. Extrude along path allows you to take two objects, a path and a profile, and extrude the profile along the path. If you're familiar with SketchUp, this is very similar to the Follow Me tool. So you select both objects, holding down Shift here, model extrude along path, and then it will ask you to select the path object. The path object turns red. So in this case, I want to click next to make this the path, and then I'm going to leave everything else unselected, and I'm going to click OK, and you'll see that it takes the circle and extrudes it along the path. There are some options available. If you select both objects and extrude along path using a scale, it will get larger as it goes. Except it's not gonna work right now, and I'll show you why. But so nothing happened. It didn't get larger as it went, because that only works when there's a smooth path. For some reason, it doesn't work with a path with sharp angles. So I'm going to undo this, and we're going to introduce a new command, modify poly smoothing. I'm going to smooth out my curve. And if I knew I was doing this, I could have drawn this originally smooth, but modify polysmoothing, smooth out the curve. Okay, now if I select both objects and use the extrude along path command with a uniform scale of 2 and making sure that I have the path object highlighted, it will get larger by a factor of 2 from beginning to end. The other option is exponential scale. So if I select both objects, model, extrude along path, make sure that the path object is highlight, and this time I'm going to use exponential scale of 2. This will get much larger. So if you need to model a sousaphone for sousacle, I guess, that's exponential scale. 4.4, extrude along path fixed profile. So the way the extrude along path normally works is it takes the profile object and aligns the center of it to the path and then extrudes the center of the profile along the path. So let's just do that. Model extrude along path. So that's our standard. But what if we wanted to alter the way the profile was extruded along the path? What if, for instance, instead of extruding the profile from its center along the path, we wanted to extrude the profile from one of its other corners along the path? And that's something we are going to want to do in Project 3. So the way that you can do that is to actually orient the profile object in 3D space to the path the way that you want it to extrude. So right now this triangle is laying down. I need to stand it up in order for this to happen. So I'm going to go to left view and modify rotate right. And then I'm going to go to top view and rotate right again. So that now, if we look at this in left isometric, you will see that the shape is facing out towards the screen. So now I can, the way this would normally extrude is the center of this would line up to the path and would extrude that way, but I'm going to set it so that this corner is aligned to the path like that. And then select both profiles, model extrude along path. And this time I'm going to tell it to fix the profile, which means take a look at the way the profile is currently oriented to the path and use that for the extrusion. So if we do that, and you'll see that this is in fact different, right? It's a different size. This is bigger in some ways. So you often want the ability to control the way the profile interacts with the path, and fixed profile does that. I have started just in general practice always aligning the object to the path and using fixed profile even when I want it to extrude along the center, because that way there aren't any surprises and I know exactly what's going to happen, and if I need to alter it later, I can do that. .1 push-pull. You should all be familiar with push-pull from week 1, but just to recap, you can push-pull polylines, you can push-pull polygons, and what must be a joke from the programmers, you can push-pull NURBs, you cannot push-pull lines. If you'll remember from earlier in this video, you can extrude lines and you cannot extrude NURBs, curves. So who knows why that decision was made. But at any rate, the push-pull tool is here. You simply click on the shape you want to push-pull and pull it or push it. Remember also the instant push-pull command. If you've drawn a 2D shape, immediately after you've drawn it, it will turn red if you hover over it, and you can push or pull it. In move face mode, which is the second mode, you can push and pull a face and it will take into account how the other faces are oriented and act accordingly, which is different than extrude face mode, which does not take the other faces into account. And the third mode is the subface mode, which is the third mode of push-pull. You can draw a shape or a line on the face of a 3D object and then select the shape, then the 3D object, and then by moving your mouse one side of the shape, this will be the subface will be highlighted, and you can push pull that. This works. Now I'm going to go back to the first mode and pull this up. This works not just with lines but also with other shapes. So I'm going to draw a rectangle using the automatic working plane here. And then if I go back to push pull back to the third mode and select the rectangle and then the shape, it will give me the option of you notice that it's only giving me the option of the rectangle here. It will let me pull that out, or if I go back to the first mode, it will let me push it back. So that are the three different modes of push-pull. (6.1) The sweep command. The sweep command allows you to take a shape and revolve it around either itself or a locus point. So if we take this shape and use the command model sweep and leave everything in its defaults, you can see that it revolves that shape around itself. When you don't tell it otherwise, it always revolves around the left-hand side of the shape. So I'm going to undo. You can see that this is the shape. But if in fact we wanted this shape, which means that we want to actually revolve around the right, not around the left, we can do that by placing a locus. This can either be a 2D locus, which is the little X here, or a 3D locus. Either one works. And if you place a locus and select a shape with the locus and run the command model sweep, it will sweep around the locus. So you need to make this solid. So that is the sweep command. Some programs may call this process lathing, but in Vectorworks this is called sweeping. There are some controls. We're going to go to 6.2. You can... Oh, it's already swept. But you get, if you look in object info, you'll get, when you go to sweep, you get these same options. You can set the radius, you can set the segment, you can set the sweep. So the segment controls how many facets there are in the sweep. So if and the normal, it's normally set to a really weird number. It's normally set to like 5.16 or something, but 5 is plenty low. The lower this number is, the more segments this would have if you could go in and look at it under the hood, and that just makes the file larger and increases the time. But so if we change this to 45, you can see what happens here, right? So it's that's what the segments do. The higher the number in degrees, if I change this to 90, it'll become a square, the lower the circular resolution is. But if you set it to 5, usually that is plenty to make it appear actually round. The sweep is the number of degrees that it goes around. So right now it's 360, so it goes all the way around. If I were to set this to 180, it only sweeps halfway around. Let me, by the way, double click on this and show you that what's going on here. There's a locus and there's a rectangle. So this rectangle is sweeping around this locus. Another interesting thing is pitch. And what pitch does is allows you to sweep around but not flatly. So if I look at this sort of from the front, you can see that this is flat. It's like a washer. If I give it a pitch of 1 inch, let's say, it will, you see what it does? It starts here at 0 and ends here at +1 inch up. So it pitches it as it goes around. And you can sweep more than 270. You can sweep, I think, up to 3600 degrees. So you can create a spiral by giving it a pitch. Anyway, so play around with the various options. You can draw your own shapes and sweep them. Model sweep. And see what the sweep tool can do for you. Next we have 7.1, the taper face mode, and as the name would imply, the taper face mode allows you to taper a face. So here is the taper face mode. The way it works is kind of interesting. You click a face, and then you click another face, and it creates basically a hinge between the two faces and allows you to angle the second face, basically. So if I click this face first and then click this face second, it's going to create a hinge right here, and it'll let me pull the second face out. Now you'll notice the note here: pro tip, disable the snaps. Right now it's wanting to snap to the grid or to the center of the other face. So if I hold down the tilde key, which is the little squiggle next to the 1 key, it disables temporarily snapping so that I can stop it anywhere I want, and it doesn't necessarily snap to one of the predefined places. So that's the first mode, the tangent faces mode of the taper face tool. I wonder what would happen. Oh, it will let me do that. Yeah, so you can get some interesting results with that. 7.2, the picked face mode. Okay, let's go back to the taper face mode for a moment and pick this face, and then click here. Gotta hold down tilde and pull this out, and you'll see what it does. Or if I do this, you'll see the result there. But then I'm going to undo both of those and switch modes and go to the picked face mode and try this again. And now it's going to let me pick individual faces. So I'm going to pick this face, and it's not actually letting me do much. So let me try picking this face instead. So here and here, I'm holding down tilde. If I don't hold down tilde, it just wants to pull it into a square, which might be useful because it's snapping it. But if I pick the first face and then hold down tilde, you'll see that I can get some interesting results there. So let's try this over here. Yeah, again, I get more results on the curved surfaces than I do on the others. So play around with these shapes, use both modes, and see what the taper face tool can do for you. The next 7.3, sorry. This is just an object that's here for you to play around with and see what you can do with taper face mode. So play around with that, see what you can come up with. Seven 7.4 is again, play with this. And also just a note about the OpenGL options. If you're getting facets, if yours looks like this, nothing's wrong. It's just that the OpenGL mode is set to display low. So I'm going to go to over here to the rendering mode, to OpenGL options, and change the detail from low to high. This doesn't affect what's actually happening in the model, it just affects the way it's being displayed on the screen. So you can control that here, and you also can control when you do the output how high resolution it has. So if you're having if you have a large drawing with lots of stuff in it and it's bogging down, if you set this to lower while you're working on it, it can sometimes speed up the process. And then right before you render, just set it to high to make sure that it looks like you want it to. But so check out the taper face and see what you can do with the various objects that are on this layer. Next we have 8.1, the deform mode. This is the deform tool. It lets you twist and taper and bulge and bend solid shapes. So there are different modes here at the top. So I'm going to select the first mode, which is the twist solid mode. And the way this works is you select the tool, you select the mode, and then the first click is you select the object that you want to twist. Then you get a protractor, and you can click the protractor on the point that you want to twist around. So that's click number 2. Then click number 3 is it asks you to basically drag a handle that you're going to use to do the twist. So I'm just going to drag straight out here. So I'm going to click, and then I'm going to pull my mouse in whichever direction I want, and when I'm happy I click again, and it twists the model around the point that you originally set with the second click, and it twists the entire model. I'm gonna show you here that you don't have to twist around a point on the actual object. I could decide I'm gonna set this as the point that I'm twisting around, and I get a very strange result. So I could twist over here. So just play around with that and see what you can do with the twisting. Next, we're going to look at the twist face mode. So in this mode, which is the second mode, it attempts to not twist the whole model, but just to twist a face, which actually usually gives you some very strange results because it's asking itself to defy physics. But so if I click here and drag out here again and twist, you'll see what it's doing. It's trying to just twist the top face, and so it's kind of destroying the object while it's twisting. So I have never found a whole lot of use for the twist face mode, but there must be a use for it because it's in the program. Some people must find it useful. Maybe you'll be one of those people that come up with a great use for the twist face mode, but give it a try. See what you can make it do. Next, we have the taper face mode. So back to deform, that's the third mode. And works in much the same way. You select the mode, click on the object first, and then it gives you this, instead of a protractor, now we have kind of a northwest, east, south arrow. So you click at the center of the thing you want to do again. So we're going to click there, and then you pull a handle in the direction you want to taper, and then you can pull out. And you'll notice that this doesn't exactly work the way that you think. If you're trying to get this to taper towards you, it doesn't really want to do that I've been able to see, at least. It will taper left and right, but I have yet to be able to get it to taper towards me or away from me. I'm going to try one more thing. Yeah, that doesn't seem to be an option. So play with it. Maybe you can make that happen, but it certainly does allow you to taper the object in a linear fashion, left and right. Next, we have the bulge mode. So it follows much the same procedure. Select the mode, click on the object, set the center, drag an arrow, drag a handle, and then you can bulge in by pulling in. You can bulge out. But once again, I don't think it's going to let you. Yeah, it's a little bit. It's coming out towards me, but certainly not in the same way that it lets you do it left and right. The bend mode is next. That's this mode. It works in the same way again. You select the mode, you select the object, click where you want to start, drag yourself a handle, click again, and then it will let you bend in a circular way around the object, the point that you created. There's two sub modes within this mode. There is the symmetric mode and the finite length mode. I'm going to turn both of those off. I'm going to click here, whoops, here. So with symmetric mode off, it only does it in one direction based on where your initial click is and your handle. That's different from if I turn symmetric mode on. It does what I did originally. It's symmetrical around your original point. And finite length mode, you're not going to see this, I don't think, but it constrains the length to, it doesn't stretch the object in order to make it bend, which it may or may not do depending on what it's trying to do in the other mode. Next we have the fillet edge tool, number 9. The fillet edge lets you select edges and round them over. So you can enter a radius here and then select an edge. It will turn red, and then click the check mark and it will round over that edge. You can select multiple edges by holding down Shift. There are also our preferences in the preferences here where you can tell it to select faces rather than edges. So instead of having to select all 4 edges, I could just click the face and do the same thing. All right, let's see what happens if I... Okay, I was surprised that worked. I thought it was going to come back and tell me that it couldn't compute the round over for some of those edges, because it does that sometimes, but that seems to have actually worked. Play around. And the other option is variable radius. You can give it. You can play with these two and see what it does. That it will alter the radius. It'll make it larger or smaller by a percentage. This is tricky to get to work, to be perfectly honest, but play with it and see what happens. So that is the fillet edge tool. Our next tool is number 10, the chamfer edge tool, which works very similarly to the fillet, only it gives you an angled edge rather than a rounded edge. So instead of setting a radius, you choose a setback here from the edge. So I'm just going to leave it 3/4. I'm going to change this back to faces, or back to edges from faces. I'm just going to select that face and check, and you'll see what it does there. It slices off the corner according to the distance back from the edge that I've set here, and it has virtually the same options that the fillet does. You can select faces, and it will chamfer them. So play around with that and see what it will do for you. Next up, we have number 11, Shell Solid. The Shell Solid tool is here. And what the Shell Solid does is enables you to take a solid and turn it into a shell. So I'm going to set a thickness here of 1 inch. I'm going to click on this face and check, and it creates, basically it turns a cube into an open box. I'm going to undo that and do it with a thinner 0.25, a thinner shell there. That probably explains it a little better. You can, if I want to go all the way through, I could select both edges, both faces. So let me undo that. And back to the Shell Solid tool. You'll notice it says use Option key to select back faces. So I'm going to select the back face first by using the Option key. So I'm going to select that face, and then I'm going to hold down Shift and select the front face. So I have both faces selected, and then if I check, it will go all the way through. So that is how you can turn a solid into a shell. There's a checkbox over here that indicates inside or outside. If it's obviously what just happened was it removed the inside of the box. It created the shell towards the inside. That's the default mode. If I uncheck inside, the box gets bigger because it creates the shell to the outside of the original box. So depending on what you want it to do, you can have it inside or outside the original shape. Finally, we have number 12, solid operations. The solid operations are addition, subtraction, intersection, and section, which allow you to do those 4 things to 2 solid volumes. So the first of those is addition. If you have 2 objects, you can see that are 2 separate objects. You can add them together. So you select them both and model add solids, and it turns it into 1 solid. I will say that you don't necessarily need to do this unless you need for these 2 things to be 1 thing. There's no reason that they can't just be 2 things. But if you need to do something else to them, sometimes you need to add them together, or if you want them to be textured the same, you might need to add them together. But just because they're sitting next to each other like this doesn't necessarily mean you have to add them together. But if you want to add them together, you can use the add solids command. 12.3, subtraction. This reminds me, I'm going to go back for a moment to add solids. So the 2D version of this is add surface. So adding surface and clipping surface and adding solids and subtracting solids are two things that are done frequently. So just be aware that the 2D version is modify add surface. It's obviously not available right now because I don't have any surfaces to be added. So 2D is modify add surface, 3D is model add solids. So now back to subtraction. So subtraction, the 2D version is modify clip surface. The 3D version is model subtract solids. So you select both solids, then model subtract solids, and it will ask you to highlight the object which you want to subtract from. So if I want to take the sphere away from the cube, I want to make sure that the cube is highlighted. If I want to take the cube away from the sphere, I want to make sure that the sphere is highlighted. So I'm going to subtract the sphere from the cube. Let's do it the other way. Model, subtract solids. Now we're going to switch and highlight the sphere, so that will subtract the cube from the sphere. And there's also an option to leave them both. So if I subtract solids, I'm going to do that again, but I'm going to retain the subtracting object. So I'm going to subtract the cube from the sphere, but I'm going to leave the cube here. So it does the subtraction, but it leaves the subtracting volume in place, much the same as clip surface leaves the clipped surface in place until you delete it. Sometimes you want the surface that you're subtracting to, or the object that you're subtracting to, actually go away, and sometimes you want to keep it for various reasons. So just be aware that you have that option. Next, we have intersection. Intersection looks at where the two volumes overlap and creates a third volume based on that overlap. So if I select both of these and do model intersect solids, it creates this volume where the cube and the sphere overlapped. And then finally, we have section. Section takes one solid and creates a section of the other solid by cutting the second solid and removing part of it. So if you select both solids and do model section solids, it will ask you to highlight the object which is doing the sectioning. So I'm going to use the yellow object to do the sectioning and then click OK. And you'll see what happens is it took the green object, cut it with the yellow object, and then removed one side. You can, in the object info, you can reverse the side of the yellow that the green is left on. This is different than subtract solids, because if I had wanted to get rid of the top of this with subtract solids, I would have to have had a solid that encompassed the entire top, whereas with the section, I just need a cutting surface, basically. So that completes our tour through the basic modeling tools and commands. Hopefully you will have a chance to use some, maybe even all of these in the next project.